I'll spend time today discussing gunshot residue analysis using the Phenom XL desktop SEM with Perception GSR. As Jessica mentioned, I am a product manager for the Phenom desktop SEM, and I have over 12 years of experience with scanning electron microscopy. I started my time using SEMs by working for Aspects Corporation, which some of you on this call may be familiar with. Aspects Corporation manufactured industrialized SEMs that specialized in automated analysis, but I'll touch base on that in a few slides. During today's webinar, I will quickly provide a refresher on SEM EDS. We will then discuss gunshot residue analysis, and I will provide an introduction into the Perception software, which some of you may be familiar with already. I will also provide information on the GSR Reporter and some of the new features that have been included in this version of Perception. So the Phenom desktop SEM, which is now produced by Thermo Fisher Scientific, it was first developed by FEI in 2006. For those of you who do not know, FEI is a leading producer in electron microscopy. In 2009, Phenom spun off from FEI and Phenom World was formed, and they've produced the Phenom desktop SEMs. For those of you who know, Aspects Corporation was acquired by FEI back in 2012, and then in 2016, Thermo Fisher Scientific acquired FEI and acquired Phenom World in 2018. So now that these companies are all under the Thermo Fisher umbrella, we were able to introduce the Perception software onto the Phenom XL platform. Here we have the current Phenom lineup of instruments. We will spend our time discussing the Phenom XL platform, but I wanted to provide a quick overview of the entire Phenom lineup. The Phenom desktop SEM was designed for ease of use. This was one of the reasons why the three systems on the right use a cerium hexaboride crystal source. I'll touch base on the importance of that in a few slides. All the Phenom desktop SEMs come with a never lost optical navigation system. An optical camera is built into the system, and an image is automatically acquired once the sample holder is placed into the system. Both bright field and dark field images can be acquired, so this can be ideal for trace evidence analysis, such as looking at fibers or glass or hair, anything of that nature. Also in Perception, the software used for GSR analysis, an image of your sample holder is automatically taken and appears in the Perception interface, allowing for the user to easily move between stubs without having to search for your samples. Moving on to the Phenom XL SEM, this is the desktop SEM for large samples and for automation. It has a 4-inch by 4-inch stage, and it can hold up to 30 half-inch stubs for GSR analysis. It also can be equipped with a secondary electron detector for topographical imaging, and of course, the EDS detector for elemental analysis. And last, the Phenom Pheros, which was introduced last year, includes a field emission gun for ultra-high resolution images. So now we'll touch base on, before we get into the GSR analysis, I'd like to provide a brief overview of how an SEM works. Shown here is a cross-section of an SEM. This is not specific to the Phenom, just an overview of SEMs. At the top, we have the source of the SEM, or the light bulb of the SEM. As I mentioned in the last slide, for the Phenom XL, this source is a cerium hexaboride source. This source produces electrons that move through the column, which is the area below. As electrons move down the column, they get focused by electromagnetic lenses. At the bottom of the column, there are deflection coils that raster the beam along the sample surface to get an SEM image. The electron beam interacting with the sample surface produces many different signals, but we'll talk mainly about 3 signals today: backscattered electrons, secondary electrons, and characteristic X-rays. We will get into the importance of each electron type in a couple slides. As I mentioned before, the Phenom was designed for ease of use. One of the strong driving forces of ease of use and low maintenance on the Phenom is the cerium hexaboride electron source. If you've used the Aspects SEM or most other entry-level SEMs, you may have used a tungsten SEM. This source and technology has been around for decades. A tungsten source can have an average anywhere from 70 to 120 hours of beam life. If you have used a tungsten source in the past, you may have had the unfortunate instance that the source burned out while imaging or running an important GSR analysis. I know the feeling of coming in the next day with the filament burned out halfway during the first analysis of a sample. I would then have to vent the system, replace the source, align the source, and wait for the beam to warm up. This is definitely not the way I'd like to start my mornings. The cerium hexaboride source of the Phenom is 10 times brighter than the tungsten source and lasts 30 times longer. There are no catastrophic failures during operation. The source just degrades slowly, allowing for scheduled replacements. And because we're not changing the source tilts, stigmation, alignments, and other maintenance is not needed as often. And once again, the cerium hexaboride source is brighter. The source allows a user to collect superior images without much effort. Here's an example of the cerium hexaboride source with a tungsten source versus a tungsten system. Not only do the images have higher resolution and show sharper edges, the images have a higher contrast range, or the images are HDR, high dynamic range. The signal to noise ratio of the image is much better than a tungsten source, and that becomes important when we're looking at this towards automated GSR analysis, which I'll make sure I touch base on further in the presentation. As I mentioned before, the electron beam hitting the sample produces several types of signals. The Phenom is equipped with 3 detectors that detect 3 key signals: the backscatter electrons, the secondary electrons, and characteristic X-rays. I'll go into examples of each detector or image type in more detail, starting with the backscatter electrons. The backscatter electron detector shows change in atomic number. Heavier elements like lead and copper show up brighter than lighter or less dense elements like carbon and oxygen. It is very easy to spot elemental change with the backscatter detector. Because the detector equipped in the Phenom SEM is a quad backscatter detector, it can also be used to show change in topography as well. The backscatter detector can also be used in low vacuum levels, so imaging non-conductor samples is possible without any sample coding. Here are some examples of backscattered images. The 2 images on the right are examples of gunshot residue particles. The bright particles or bright phases are likely the heavy elements characteristic to gunshot residue. The backscatter electron detector is also used for the automated analysis to search for gunshot residue. And because the lead, barium, and antimony are characteristic elements of GSR, they tend to appear bright on a carbon stub, which is typically the substrate material. We'll cover the importance of this in a couple slides as well. The next signal that we'll discuss are secondary electrons. Most images you may have seen in a textbook or published paper are probably secondary electron images. They show change in topography. It is a very surface-sensitive technique. Because of the position of the detector, the secondary electron detector shows shadowing very well, so that they can make topographical surfaces really stand out and look appealing. This is why the secondary electron imaging is great for fracture or failure analysis, among other types of analysis. Here are a few examples of the secondary electron images. The first image is a fatigued fractured surface. You can really see the pitting and other topographical information that help material scientists. The next image is a picture of an ant leg where you can see the hairs of the ant sticking out. The secondary electron detector can be used to confirm the morphology of gunshot residue particles as well. During the relocation portion of gunshot residue analysis, some microscopists would take a secondary electron image to see if it's spherical or if the particle is spherical or not. These are just a couple examples of the type of information you can gather from the secondary electron detector. Now, lastly, we will talk about EDS analysis, or energy dispersive spectroscopy. EDS analysis provides elemental compositional information. This complements the backscatter detector very well, which shows the change in elemental composition. The EDS detector for the Phenom platform is a fully integrated silicon drift detector. One software package controls the SEM imaging as well as the EDS analysis. The takeoff angle is 29 degrees, which is the highest takeoff angle for any desktop SEM. And because the source is a cerium hexaboride source, we see a much higher EDS count rate compared to a tungsten source. Here are examples of an EDS spectrum. This is a piece of galvanized steel. The coating which point 1 shows is a high zinc percentage, and the material is coated with zinc. But then the corroded portion shows a high iron percentage, which is the layer underneath. This was performed with an easy point and click. For those of you who have used the perception software previously, you may remember having to perform EDS analysis on the right image. Now EDS analysis can be performed on a single image and is as easy as just selecting the area you want to acquire an EDS spectrum from. Also included in perception software is the elemental mapping, or EDS mapping. A full EDS scan is performed at each pixel, and a color is assigned for each element. This provides a colorful representation of the elemental composition of your sample. Also included in the Phenom XL is fast mapping, which allows the user to acquire EDS maps within minutes. So combining the fast mapping algorithm with the bright cerium hexaboride source, you're able to generate some of the best EDS maps of any desktop SEM quickly. Now that we have gone through a brief refresher on scanning electron microscopy with energy dispersive spectroscopy, I'll now talk about gunshot residue analysis and provide an introduction into the perception software. Although I believe if you're on this call, you have an idea of what gunshot residue is, but for those of you who do not know, gunshot residue is the particulate formed when a firearm is discharged. A plume or a cloud of particulate is formed in the air around a discharged firearm. The particles that are characteristic of GSR is lead, barium, and antimony. These particles can deposit on the hands, body, and clothing of a shooter or the surrounding area. ASTM E1588 is just one of the guidelines that's used for detecting GSR particles using SEM EDS, although there are other guidelines such as MC. The standard method for collecting gunshot residue for SEM EDS analysis is using an adhesive carbon stubs. The adhesive is used to pull GSR particles from hands or any other surfaces that may have come in contact with GSR particles. Typically, stubs are focused on the back and palms of hands. So stub kits typically come with 2 stubs or 4 stubs and can be separated by hand or as specific as like the left hand palm, left hand back, right hand palm, right hand back. Clothing are typically bagged, and if needed, the adhesive stubs can be used to sample portions of the front or of the clothing, or whichever portion of the clothing that would have been in range of the particulate generated from a fired or discharged firearm. The adhesive stubs can also be used on other surfaces, such as within a car and things like that. So why use automated SEM EDS analysis for GSR analysis? Historically, atomic absorption was used for analysis. Cotton swabs was used to collect samples from the hand and palm of a shooter or from the surfaces, other surfaces. Atomic absorption provided bulk chemistry information and would provide overall chemistry of the lead, barium, and antimony, but would not show that all three were together in one particle. Also, particles could fall off a cotton swab in shipping or storing of these samples. SEM EDS analysis has the ability to not only provide elemental composition, but can confirm all three elements that are characteristic of GSR are found in just one particle, and we can provide the morphology of the particle. Manual SEM EDS can be performed, but that is time consuming. I do not believe any scientist wants to or has the time to look for submicron particles manually at high magnifications. So automated SEM EDS analysis can also take away the user bias. Analysis can be performed overnight, and the instrument can be used to review the data and used for other SEM EDS testing during the day. So now that we've talked about why automated SEM EDS analysis is used for GSR analysis, we'll now talk about what is needed to set up a run using the Perception software on the Phenom XL desktop SEM. This may be familiar for those of you who've used an Aspects SEM and are familiar with the Perception software. The first thing you need to do is set up a stage file or tell the instrument what area you want to analyze. This is typically set by setting up 3 points per stub. A new addition to this version of Perception, though, is that the image is automatically acquired and placed into the system, unlike having to use the macro navigator or remember to use the macro navigator and take a picture before you placed your samples and the stage into the system. The next item that is needed are the settings for the analysis. Settings such as magnification, resolution, threshold settings, these are all settings that is now done in the recipe builder. The recipe builder is new to this version of Perception and allows for more automated features to be included in the analysis. I'll go into more details about the recipe builder in the next section. The next items that are needed to legacy Perception users, and that is the vector file and rule file. The user must provide the elements that are of interest, and this is done using the vector file, as well as the rule file. How are those elements going to be classified? The rule file is a list of true-false statements that are used to classify each particle either based on elemental composition or morphology parameters. The good thing is that the legacy vector files and rule files from old Aspects instruments can be used in the new software as well. And last, you need to be able to put in your sample ID information or sample descriptions. Once that information has been added into the software, you can press play and the automated analysis will begin. So once you hit go, the first thing the system will do is create stage fields based on the analysis and magnification settings. The system will go with a low resolution and low magnification set by the user and search pixel by pixel, field by field, looking for particles that meet the detection threshold. Users of the legacy Perception may be familiar with the dual threshold system of the automated analysis. The analysis is designed to search quickly but measure accurately using this dual threshold system. And because of the high signal to noise ratio caused by the bright cerium hexaboride source, the searching can be done quicker than a tungsten source without missing the small GSR particles. So once it finds the particle that meets the detection threshold, the system will move into measure mode and measure the particles of interest and immediately perform EDS on that particle. This is important because the EDS is formed on the particle without having to worry to go back to find the particle, or if there's having to worry that there might be a beam shift, causing you to miss the particle when you go back to analyze it. So since the EDS is performed right away, the spectrum and parameters for each particle is then saved. Approximately 20 to 30 parameters are saved for each particle, and based on the classification rules, they will classify this particle. Then the analysis will continue and move on to the next particle. And here's a video of the analysis running. You can see the analysis moving field by field, finding particles that meet the detection threshold and immediately collecting EDS for each particle. You can also see that a spectrum appears in this video, as well as an image of each particle is saved. This can be adjusted in the rule to save only images of particles of interest, like the particles that are characteristic of gunshot residue. And once again, because of the bright cerium hexaboride source, the signal to noise of the image is higher, so image scans are quicker and the EDS counts are higher. So for those of you who have experienced using the previous version of Perception, the new interface is actually a one monitor interface instead of two, and the two monitor interface that you're used to. EDS can be acquired on one screen, but it does still support the dual image interface for those of you who liked the dual image on the right monitors of the old software. EDS can be acquired with one click, and other manual SEM EDS functions are also available, such as EDS mapping. This version also includes auto functions such as autofocus, auto tilt adjustments, and auto video. And I'll talk about that once we get into a little bit of the recipe builder. So just to summarize, the 4 items that are needed in Perception to run GSR analysis is the stage file or the area selected for the analysis, the recipe information or analysis parameters, a vector file and rule file for EDS analysis, and then the analysis information such as sample ID. And then the system will move field by field, look for the particles of interest that meet the detection threshold, save the image, immediately collect EDS, classify that particle, and store that information. And once again, because of the bright cerium hexaboride source, this can be performed quicker than a tungsten source. So for the last section of the presentation, I will discuss the GSR Reporter and some of the new features that are included in this new version of Perception. Those of you who have GSR experience may know that although the automated SEM EDS analysis finds and records the GSR particles, it is still necessary to relocate those particles and confirm they are in fact particles that are characteristic to GSR. The Perception software has a built-in reporter for this that allows you to relocate these particles with one click. The particles in the GSR Reporter are separated by classification to easily review the particles of interest, and with a single click, the stage can be moved to that particle. The stage for the Phenom XL desktop SEM is much faster and more accurate than the traditional aspects stages, or so relocating small particles are a lot easier and a lot quicker to find. And now also with a single click, you can collect EDS of the particle. A helpful feature of the new GSR Reporter is that an overlay of the spectrum during the run is shown, so you know you're relocating on the particles of interest and not necessarily another bright particle in that field of view. The GSR Reporter is built into the Perception software, and within the reporter, you are able to save the relocated information with a single click, and a report can be generated. So once the relocation of the particles are completed, a word report can be created. These reports meet the ASTM and MC guidelines. This report will pull information from the run analysis, such as quality check on copper or the relocated particle information. These reports can be customized to meet your internal requirements as well. No report modifications are required, and reports are ready for use immediately with the forensic lab's letterhead. And for legacy aspects users, the traditional word reports that were used in the older software can be used in the new perception software as well. So I want to talk about some of the updates to perception, and I've talked about the recipe builder a few times with the recipe builder that is on the new version of the software. But first, once again, I've also mentioned that the cerium hexaboride source is brighter and more stable. And because of the stability of this source tilt checks and stigmatization corrections are not needed as often. So you don't have to worry about the filament saturation or training a new user on how to properly saturate the filament, because you will not run into a catastrophic failure with the source. It will just where the source just burns out on you. That is not seen with the cerium hexaboride source. But also with the new version of perception, the recipe builder allows for the auto tasks to be set for the analysis. Auto tasks such as source alignment checks, autofocus, and auto EDX calibration can be set. The recipe builder is a list of tasks from the start of the run to the end of the run, or all the tasks that could be done in between each run. This allows for some of the checks that advanced users typically do before the automated run, like set the spot size or set the accelerating voltage. All that could be done automatically now. And these are items that are sometimes missed by beginner users. So recipe builder is helpful in that sense. Another update to the recipe builder and AFA template is the ability to group stubs together by project or case. I've been told that this has been a feature request for past users of the perception software. Now you can actually group stubs by case or project, and once a certain classification meets the particle count requirements, the remaining stubs can be automatically skipped. This is helpful for cases that have several characteristic GSR particles on the first stub, so analyzing the remaining stubs would be unnecessary. And that way you're saving time and analyzing the next several cases that can be loaded in at once. So just to summarize what has been covered today, the Phenom XL Desktop SEM is an integrated SEM EDS system that uses a cerium hexaboride source to provide a bright SEM image with a high signal-to-noise ratio, high EDS counts, and no catastrophic failures. The Perception GSR software is one interface that controls the SEM imaging and EDS analysis. The automated SEM EDS analysis is used for gunshot residue analysis, provides the size, shape, and elemental composition for each particle. The GSR Reporter allows for easy relocation and ability to confirm GSR particles and the ability for one-click reporting. Also, updates to Perception allows for customized recipes with auto functions that can assist beginner users to gunshot residue and perception. I hope this webinar was helpful and answered some of your questions you may have regarding using SEM EDS for GSR analysis. I will pass the presentation off to Jessica for the last poll question.